Assalamu alaikum. I am starting a new chapter, that is chemical equilibrium. Let us first study about the reversible and irreversible reaction. Reversible reaction are those where the reactants convert into product and the product again converts back into reactant. This is an example from the vapor pressure where the liquid converts into vapors and the vapors convert back into liquid. We can see here that the reactants are converting into product and the product is converting back into reactant. Such kind of reaction is known as reversible reaction. And when a reaction where the reactant is converting into product but the product is not converting back into reactant is known as irreversible reaction. The arrows are showing here that there is forward as well as backward or reverse reaction. Here only forward reaction is taking place. Now coming towards the reversible reactions and dynamic equilibrium. Let us again clear our concepts. Taking an example of this reaction where N2 and H2 react to form NH3. But then we see that after the formation of this NH3, after the formation of this product again breaks down into N2 and H2. Which means that the reactants are converting into product and this product is again converting back into reactants. So we can write this reaction in this way, forward arrow as well as reverse arrow. So the reactants converting into product and the product is again converting into reactants. Now let us take a general reaction where A and B reacts and form C plus D. Initially, we see that the reactant concentration is same. Obviously, if a reaction is started, the reactant concentration is same and the product concentration is 0. When a reaction starts, it suddenly does not goes to completion. Okay, first there is some reactant, then with the passage of time, it converts into product. Now, we say that initially, the reactant concentration is same whereas the product concentration is 0. But with the passage of time, as the forward reaction proceeds, the concentration of reactant decreases. Why? Because they are used for the formation of product. So reactant concentration decreases and that of the product, their concentration increases. This means that now the product concentration is increased. So now product will convert into reactant because their concentration is increased. Therefore, we say that rate of forward reaction decreases and rate of backward reaction increases. Now we say that a stage reaches when both the reactant and product concentration becomes equal. This type of condition is known as equilibrium. This is known as equilibrium. Now, what is dynamic equilibrium? Dynamic equilibrium is a condition when the concentration of reactant and the concentration of product does not change. They become constant. They do not change. But still the reaction is going on. The reactants are converting into product and product is converting into reactant. Such type of condition, such type of equilibrium is known as dynamic equilibrium. We have another type of equilibrium, that is static equilibrium. Now the next topic is law of mass action. According to the law of mass action, rate or speed is directly proportional to the product of active masses. Now what does this statement means? We will see here in the derivation. We have taken reactants A and B which converted into product C and D. Now rate of forward reaction R1 is directly proportional to AB. Okay. Now, whenever we remove the sign of proportionality, we write a constant. In your books, the constant is taken as K1. But the constant can also be taken as Kf. Kf denotes constant for the rate of forward direction. Now, rate of backward or reverse reaction is equal to R2, which is directly proportional to CD. Right? Rate of reverse reaction will depend on the product. So, R2, we remove the sign of proportionality and wrote a constant K2. Here we can also write a constant Kr. Okay, and we wrote the product C and D. Now see here, Rate of forward reaction is directly proportional to the product of masses to the product of reactant. So what does law of mass action says? That rate or speed of a reaction is directly proportional to the product of active masses. The masses which are taking place in the reaction is directly proportional to the masses taking place in the reaction. Which masses take place in the reaction when we go in the forward direction? It is the reactant. So rate or speed is directly proportional to product of active masses. Directly proportional to product of active masses. Directly proportional to the product of active masses. Now, I hope you understood this point. Coming towards at equilibrium, what happens at equilibrium? That the rate of forward reaction become equal to the rate of reverse reaction. Now, therefore, we can write it as, we wrote here as R1 is equal to K1 AB and R2 is equal to K2 C into D. Now, we wrote here as they both are equal to each other at equilibrium. Now, what we did, that we took Kc over there and A and B over here. It became K1 divided by K2 which is equal to CD divided by AB. Now we see here that K1 divided by K2 is equal to Kc, where similarly the Kf divided by Kr, rate of forward and rate of reverse reaction, is also equal to Kc. So we can write here the equilibrium constant Kc, which is equal to Cd divided by AB, product divided by reactant. We will discuss this example at the end of the lecture. So from the law of mass action, we know that what is equilibrium constant? Equilibrium constant Kc is equal to product divided by reactants. Coming towards another example, in this example they tell us that the NO is breaking down into N2 and O2. In the question it is given that there is 1 mole of each. While writing the expression for the Kc, that is product divided by reactant, when we wrote the product divided by reactant, we will write 1 mole per dm cube for each. Here there is a 2 before NO, so we will write it in a square form. So 1 mole for each and 1 mole for NO, but with the whole square. When we will open this whole square, we can write it in this form: 1 mole per dm cube into 1 mole per dm cube. Now after writing it in this way, we can see that all the mole per dm cube can cancel each other. Hence we get that in this case Kc has no unit. Remember that Kc may or may not have any unit. Now coming towards the other example where H2 and I2 combines together to form 2HI. Here we have to calculate the value of Kc from the concentration of reactant and product. Now we see here that the concentration of both the reactant is given as 0.04 mole per dm cube and concentration of product is 0.08 mole per dm cube. So when we write the Kc, which is product divided by reactants, now the concentration of product is given 0.08 mole per dm cube and the concentration of reactant, here see both reactant, it means that 0.04 for each H2 and I2. So 0.04 for H2 and 0.04 for I2. After calculating all these and opening this and calculating all these values, we get the answer 4. So the value of Kc is 4. Now coming towards the other topic, that is importance of Kc. Now what is the importance of Kc? There are 3 main things that Kc tell us. It is the direction of reaction, extent of reaction and effect of external conditions on the position of equilibrium. Now direction of reaction. How Kc tell us the direction of reaction? I wrote here that ratio less than Kc, the reaction will move in the forward direction, ratio greater than Kc, it will move in the reverse direction, and ratio equal to Kc, it means that the reaction is at equilibrium. Let me give you a brief explanation for each point. Over here I took the example that H2 and I2 is combining and forming 2HI. Value of Kc, that is 57 at 700 Kelvin. Now we took the sample from the reaction mixture, sample of each H2, I2 and 2HI from the reaction mixture at any time. either after 5 minutes, after 10 minutes, we took them out from the reaction. We determined their concentration and their concentration at that particular time. That's why I wrote here T with each. H2 T, I2 T, HI T. That at a particular time we took them out of the reaction. Their concentrations that we determined are H2 0.01 mole per dm cube, 0.20 of I2, and HI is equal to 0.40 mole per dm cube. Here we wrote T. T is mean that the concentration measured at some time, not at equilibrium. It means the reaction is not at equilibrium. It has not reached equilibrium at some particular time. Before equilibrium, we took the samples out of the reaction mixture and determined their concentrations. Now, if we take these concentration in terms of an equilibrium constant, then we will write QC. QC is also equal to product divided by reactant. But have a look, we took the concentrations at a particular time. If we took the concentrations at equilibrium, then we would have written here Kc. Okay? Product divided by reactant at particular time. The reactant and product at a particular time. Hi divided by H into I2, all at T. When we wrote all these concentrations, we got an answer 8. Solve this and tell me in the comment that either this calculation is correct or not. I have already told you that if we have not taken the concentrations at T and equilibrium is established, then we would have used Kc over here. Have a look on this reaction where H2 is combining with I2 and forming 2HI, which was at Kc equal to 57 at 700 Kelvin. But when we calculated the value for QC, we got the answer 8. Now, we can see here that the Kc is equal to 57, whereas QC is equal to 8. It means that QC here is less than Kc, because 8 is less than 57, right? So QC is less than Kc. So when QC is less than Kc, it means that the reactant will convert into product, which means that forward reaction will take place. There are 3 conditions: that the value of QC is less than Kc, the value of QC is more than Kc, or the value of Kc is equal to QC. In these conditions, we will know that either the reaction will move in forward direction or not. Ratio of QC less than Kc. So reaction will move in the forward direction. Now QC ratio greater than Kc, it will move in reverse direction. And the ratio equal to Kc, it means that equilibrium is established. I hope you understood this topic. Further, I will solve some MCQs related to the importance of Kc and other topics of this chapter, so your concept will be more clear. Now coming towards the second point, that is the extent of reaction. We all know that Kc is equal to product divided by reactant. One thing we know is that when we will have a small value in the denominator, we will get a large value as an answer. Right? Taking an example of 10 and 1 means the product formed is 10 and the reactant is 1. When we will divide it, we will get an answer of 10. On the other hand, if the denominator is greater, we will get a small value. And when they both will be equal, we will get an answer of 1. Now, have a look over here. We see here that the product formed is 10 and the reactant is 1. It means that almost all the reactant is converted into product. It means that reaction is almost complete. When product is 1 and reactant is 10, okay, we get an answer of 0.1. In this case, we can see that a very small change in reactant formed a product at equilibrium. Kc shows the equilibrium, right? So, a very small reactant formed the product and an equilibrium is established. It means that this type of reaction who has a very small value of Kc will never go to completion. Why will it never go to completion? Because very small amount of reactant is used in the formation of product at equilibrium. This is why such kind of reactions never go to completion. Now, other is when the product is 5 and the reactant is 5, both are equal. We get an answer of 1. It means that at this stage, equilibrium is established. Now the next is that what is the effect of change of external conditions? Now when we will change the external condition of any reaction, the reaction will disrupt due to pressure change, temperature change or any other change. Soon the system again goes to equilibrium. It adjusts itself and goes back to equilibrium. Now what are the conditions for equilibrium? The first condition for the equilibrium is that equilibrium is established in a closed vessel. In a closed vessel, in a closed container. Okay? Now what will happen if we take an open container? Now here the container is open, but soon we will observe that all the reactants and the product, if formed, will escape from the container. It will go out of the container. This is why such kind of reactions for the attainment of equilibrium is taken place in a closed vessel. Now when the vessel is closed, the reactants will combine together and form product and no one will escape outside. So equilibrium will easily be established. The third condition is a catalyst. They say that catalyst only speeds up the reaction. It does not change the concentration of reactant or product, it just speeds up the reaction in the forward as well as backward direction. Means the reactant will quickly react in the presence of catalyst and form a product, and the product will quickly break down in the presence of catalyst and form reactants. Now see, in this example they tell us that the reaction is happening in the forward direction. So what will be the value of Kc? The value of Kc's are given as 10 raised to power 2, 30, minus 30 and 1. Now what is happening in this reaction? That the reactant is converting into the product. Forward reaction is happening, so reactant is converting into product. So the concentration of product is increasing. Right? Concentration of product is increasing. It means that concentration of product is more than that of reactant in this case. We saw over here that when the concentration of product is more than that of the reactant, the answer will be very large. See over here that here the value of Kc is 10 raised to power 2, 10 raised to power 30, 10 raised to power minus 30, which is very small, and 1. So which is the biggest Kc value over here? It is 10 raised to power 30. So we say that here the reaction is moving in the forward direction, the reactants are converting into product, the product concentration is more than that of the reactant, that is why the value of Kc will be very large. So we took the answer, the value of Kc will be 10 raised to power 30. Now it's time for solving some MCQs to make your concepts more clear. The reaction which proceeds in both the directions is called reversible reaction, irreversible, spontaneous or non-spontaneous. It is known as reversible reaction. Active mass of a substance is dash in a dilute solution. It is mole per dm³. Now what is the unit of Kc? From the example we solved, we know that Kc may or may not have any unit. So the correct answer is D. Now the next is that which one of the following is not determined by Kc? When we studied the importance of Kc, we learned that there are three main things which are determined by Kc, that is the extent of reaction, direction of reaction and the effect of external conditions. And in the effect of external condition, we studied about the catalyst, that the catalyst increases the rate of reaction. It speeds up the forward and the backward reaction. The third point is the only one which we did not study in the importance of Kc. So it is the third one which is not determined by Kc. Now in this example, a reaction is given and we have to find the expression for Kc. We know that Kc is equal to product divided by reactant. We have already solved a similar example like this before. So solve this one and the next one that I am going to show in this video and comment below the correct answers. In this MCQ, they are asking that we have a reaction quotient QC and equilibrium constant Kc. So in what case the reaction will proceed in the forward direction? In what case the product formation will take place? We know that when QC is less than Kc, the reaction proceeds in the forward direction. So the correct answer is C, in which QC is less than Kc and reaction will proceed in the forward direction.